Laplace transform of elementary functions. Learning objectives. At the end of the topic, students are able to, first one, recall and write the formula of Laplace transform of elementary functions. Second, apply the formula to obtain Laplace transform of given function. By using definition of Laplace transform, we can find Laplace transform of some standard functions. Case 1. Laplace transform of standard function e to the power at when a is constant. Let f of t equal to e raised to at. Put this value of f of t in the definition of Laplace transform. We get Laplace of e raised to a into t is equal to integration 0 to infinity e to the power minus st into e raised to at dt. Simplify the right hand side. We get Laplace of e to the power at equal to integration 0 to infinity e raised to minus in bracket s minus a into t dt. After integrating the right hand side with respect to t and put the limits from 0 to infinity, we get Laplace transform of e raised to at is equal to e raised to minus infinity upon minus in bracket s minus a minus in bracket e raised to 0 upon minus in bracket s minus a. We know that e raised to minus infinity is 0 and e raised to 0 is 1. So that Laplace transform of e to the power at equal to 1 upon s minus a. This is the standard formula of Laplace transform of e to the power at. When we replace a equal to minus a in this result, we get Laplace transform of e to the power minus at is equal to 1 upon s plus a. Remark, if we put a equal to 0 in above results, we get Laplace of e raised to 0 equal to 1 upon s plus 0. That gives Laplace of 1 equal to 1 upon s. Case 2. Laplace transform of sin at and cos at. Let f of t equal to sin at. Put the value of f of t in the Laplace transform of f of t. That is the Laplace of f of t equal to integration 0 to infinity e raised to minus st f of t. This is the definition of Laplace transform. Then we get Laplace of sin at equal to integration 0 to infinity e to the power minus st sin at dt. Integrate the right hand side with respect to t using standard formula of integration, which is integration e to the power ax into sin bx dx is equal to e to the power ax upon a square plus b square into bracket a into sin of bx minus b into cos of bx. After integrating the right hand side with respect to t using this formula, we get Laplace of sin at equal to in bracket e to the power minus st upon square of minus s plus a square in bracket minus s into sin at minus a into cos at when t running from 0 to infinity. After putting the limits of t in the right hand side, when t equal to infinity, we get 0 minus when t equal to 0, we get e raised to 0 upon s square plus a square into bracket minus s into sin 0 minus a into cos 0. But we know that sin 0 0, cos 0 is 1. So that Laplace transform of sin at equal to a upon s square plus a square. Similarly, we can determine Laplace transform of cos at, which is equal to s upon s square plus a square. Case 3. Laplace transform of standard function hyperbolic sin at and hyperbolic cos at. By definition of hyperbolic function, hyperbolic sine at is defined as e to the power at minus e to the power minus at upon 2, and hyperbolic cos at is defined as e raised to at plus e raised to minus at upon 2. Now, Laplace transform of hyperbolic sine at is equal to 1 by 2 into Laplace transform of e to the power at minus e to the power minus at. Separate Laplace operator for each term in bracket and use a standard formula of Laplace transform of e raised to at and e raised to minus at derived in case number 1. We get Laplace of hyperbolic sine at equal to 1 upon 2 in bracket 1 upon s minus a minus 1 upon s plus a. When we simplify the right hand side, we get Laplace transform of hyperbolic sine of at equal to a upon s square minus a square. Similarly, we can determine Laplace transform of hyperbolic cos of at as s upon s square minus a square. Case 4. Laplace transform of another standard function t to the power n when n is constant. Let us suppose f of t equal to t raised to n. Put this value of f of t in the definition of Laplace transform. We get Laplace of t raised to n equal to integration 0 to infinity e to the power minus st into t raised to n dt. To integrate the right hand side with respect to t, we have to use the substitution method. So here put s into t equal to x. From this t equal to x upon s and dt equal to 1 upon x dx. As t tends to 0 to infinity, then x is also tends to 0 to infinity. By making this substitution, we get Laplace transform of t raised to n equal to integration 0 to infinity e raised to minus x into x raised to n upon s raised to n plus 1 dx. Take 1 upon s raised to n plus 1 outside the integration, and by definition of gamma function, the integration 0 to infinity e to the power minus x into x raised to n into dx is equal to gamma of n plus 1. Hence, we get Laplace transform of t raised to n is equal to gamma of n plus 1 upon s raised to n plus 1. Laplace transform table. List all above derived Laplace transform formula in tabular form and remember it. We already derived Laplace of 1 equal to 1 by s, Laplace of e raised to at equal to 1 upon s minus a, Laplace of e raised to minus at equal to 1 upon s plus a, Laplace of sin at equal to a upon s square plus a square, and so on up to Laplace transform of t raised to n is equal to gamma of n plus 1 upon s raised to n plus 1. We have to remember this table to solve the examples. Now some illustrations. Example 1. Find Laplace transform of e raised to 5t plus e raised to minus 6t. First of all, separate the operator L to each term. So we get Laplace transform of given function is equal to Laplace of e raised to 5t plus Laplace of e raised to minus 6t. To write the Laplace transform of these two functions, they are belongs to case 1, e raised to at type. Therefore, using Laplace transform of e raised to at and Laplace transform of e raised to minus at formula, we write Laplace transform of e raised to 5t as 1 upon s minus 5 and plus Laplace of e raised to minus 6t is 1 upon s plus 6. So this is the answer to the given question. Now example number 2. Find the Laplace transform of e raised to minus 10t plus sin 3t plus 9. Here sum of 3 terms are there. Hence we separate L operator to each term and we get it is Laplace transform of given example is equal to Laplace of e raised to minus 10t plus Laplace of sine 3t plus Laplace of 9. 9 you can write 9 into 1. Then by using case 1, Laplace of e raised to minus 10t is 1 upon s plus 10 plus Laplace transform of sine 3t by case number 2 is 3 upon s square plus 3 square, that is 9, and plus third term 9 you can write outside, then Laplace of 1 is 1 upon s. So this is the required answer to the example 2. Now example number 3, find Laplace transform of t cube plus sine 5t into sine 3t. First of all, we simplify sine 5t into sine 3t. This product is not in our standard form. So using 2 sine A sine B formula. So we write sine 5t into sine 3t equal to 1 upon 2, 2 into sine 5t into sine 3t. That is equal to 1 by 2 in bracket cos of 5t minus 3t minus cos of 5t plus 3t, using the trigonometry formula 2 sine A sine B. Okay, that is equal to 1 upon cos of 2t minus cos of 8t. Therefore, Laplace transform of given example equal to Laplace of t cube plus 1 by 2 Laplace of cos 2t minus cos of 8t. Now separate the L operator for each term in bracket. Then Laplace transform of given example equal to Laplace transform of t cube is gamma of 3 plus 1 upon s raised to 3 plus 1 plus 1 by 2 in bracket Laplace of cos 2t is s upon s square plus 2 square minus Laplace of cos 8t is s upon s square plus 8 square. So after simplification we get Laplace transform of t cube plus sine 5t into sine 3t is equal to gamma 4 upon s raised to 4 plus 1 by 2 in bracket s upon s square plus 4 minus s upon s square plus 64. Find Laplace transform of hyperbolic sine 6t plus cos square t. First of all, simplify cos square t, express it in terms of multiple angle, so that Laplace transform of hyperbolic sine 6t plus cos square t equal to Laplace of hyperbolic sine 6t plus Laplace of cos square t, that is equal to Laplace of hyperbolic sine 6t is a 6 upon s square minus 6 square plus cos square t can be expressed as 1 plus cos 2t upon 2. Therefore, Laplace of 1 plus cos 2t upon 2, that is equal to 6 upon s square minus 36 as it is plus 1 by 2. Laplace of 1 is plus Laplace of cos 2t, and that is equal to 6 upon s square minus 36 plus 1 upon 2 in bracket 1 upon s, it is a Laplace of 1 plus Laplace of cos 2t is s upon s square plus 4. Assignment. Knowing the table, find out the Laplace transform of these 5 examples as a assignment.